Okay, I'm going to work these out step by step like I did in class. Okay, so let's look at number 1. We have a box on the floor. A 3-kilogram box on the floor. The coefficient of friction is given by this equation, where f, lowercase f is the friction, and the capital N in the box is the normal force. So if I drew the picture of this situation, a free body diagram, I'd have the weight going down, the normal force is the floor pushing up against the box, and I have an applied force. Okay, I'm trying to find the applied force. Okay, there's coefficients of friction, so there has to be friction. Now, since it's moving, this would be kinetic friction. If it wasn't moving, it'd be static friction. So I'm going to put a little subscript K on the F and the mu. Okay, so this is kinetic friction because it's moving. If I'm going at constant speed, that means there's no net force. Net force is 0. The applied force has to equal the kinetic friction, the opposing force between the floor and the box. And that's what I'm looking for. So the equation for Fk, I'm going to take that equation on my equation sheet and just rearrange it. So F equals mu N. Okay, so mu K is 0.1, that was given. The normal force is equal to the weight. The weight is mg, look on your equation sheet. Okay, so the box is 3 kilograms, that's the mass, times acceleration due to gravity is 10, so this comes out to 30. And so 0.1 times 30 is 3 newtons. So that's what the kinetic friction is, acting between the box and the floor, but it's also equal to the applied force, and that's my question. What force do I have to apply? Now, why is it equal? Because it's going constant speed. The forces are balanced. There's no net force. Okay, let's go to number 2. Same situation. Find the applied force A that is needed to get box to be on the verge of moving. So what's the maximum A that I can put on this box, applied to this box, in order to not let it move? But if I put any more, it will start moving. So I'm going to use the coefficient of static friction because it's not moving, it's on the verge of moving. And the equation for that, or let's draw the picture. It's the same picture. There's the box, there's applied force, that's what I'm trying to find. We got normal force, same as before. We got weight, same as before. But this is static friction. And since it's on the verge of moving, it's the maximum static friction. Okay? So, I'm trying to find A, the applied force, capital A, is equal to the maximum static friction. And by definition, I mean, I can use the same equation I used up here, but I'll put the S on it instead. Okay, so this is maximum static friction when you use this equation. Okay, I put that in the wrong place here. Okay, so mu s is 0.2. Normal force is still the weight, which is the mass times g. I did that right there. So that's 30. 0.2 times 30 is 6 newtons. So I'd have to apply a force of 6 newtons to counterbalance the maximum static friction. Now, if I go beyond that, you would not have Fs max there anymore. You would have Fk. Okay, so let's look at number 3. Again, we did these in class. I'm just giving you a step-by-step verbal one in case you want to go over it as step-by-step instead of just looking at the answers. So let's look at this one. Now we're accelerating to the right. So the forces are not balanced. So if we do a free body diagram, we still have the same normal force. We still have the weight pointing down. We have this applied force, which we're trying to find. And we have some friction. Now, what kind of friction is it? Static or kinetic? Well, if you're accelerating, you're moving. Okay, so you have to use kinetic friction. We already solved that. Now, the forces, the A is going to be greater than the friction force because it's accelerating. It's an unbalanced force. And I can say the net force is going to equal the bigger one minus the smaller one. Now, why is A bigger? Well, because the force that's in the same direction as the acceleration is the bigger force. And you subtract the other one from it because it's opposing it. Okay, so I had to find what net force is. I already have Fk from before. Fk is 3 from over here. So let me just write this over again. And then EF is MA. Okay, that's the second law equation. Net force equals MA. So the mass is 3, right? Acceleration is 4. And so I have 12 equals A minus 3. So A equals 15 newtons. So I'd have to apply a force of 15 newtons in order to get an acceleration of 4 meters per second squared if there's this friction opposing it. So I just solved letter B. Okay, the applied force. I just solved letter B right here. Now, the net force is equal to 12. Okay, I did that for letter A. So letter A's answer is net force equals 12 newtons. Okay, I guess I did letter B first. Okay, you okay with that? Net force equals MA. It equals 3 times 4 equals 12 newtons. So that really should go for letter A. Okay, let's look at number 4. And I forgot to tell you something here. Let's say, this force right here, I should have told you this. This applied force is going to equal, let's say it's going to equal 2 newtons. Okay? Let's say it's going to equal 2 newtons. I should have given you that. Okay, and it's moving. Find the net force acting on it. Okay, well, I can't use sigma F equals MA yet because I don't have A. Okay, so can't use that. So let's think this out. Let's draw the free body diagram. Okay, so we have 2 newtons pointing this way. Now it's moving, so the kinetic friction has to be kinetic friction. We already figured that out to be 3. Okay? Now, you have normal force and you have weight, but again, those cancel out. So, what is the net force? The net force, MA, but I don't have the A's, like I said. So, it's the bigger force minus the smaller force. So, it's in this case, it'd be Fk minus A, because the bigger force is the friction. So that'd be 3 minus 2 equals 1 Newton. Solve for the acceleration of the box. It's MA. Now I can use this because I have the net force is 1 to the left. So 1 to the left is the mass, which is 3 kilograms times A. So A is 1/3 meters per second squared to the left. So it's slowing down. Okay, so again, number 4, I need this should have been given. This information about the applied force. I forgot to write that. And I didn't do that one in class, but you should be able to do that.